Here are some examples for solving systems of inequalities. So a system of an inequality is two or more inequalities that we need to graph on the same coordinate plane. And the solution is going to be where the shading overlaps. So a solution for a system of equations was when the lines would cross and that point of intersection was the solution. And now we're going to have a full area. So let's go ahead and graph this first inequality here in blue. It says 4 is greater than 4x minus 3. So this is in slope-intercept form, so we're going to put our first dot at -3. And then our slope is positive 4/1. I'm going to add one more line there, or one more dot. And now our line needs to be dashed because we are dealing with a greater than sign, not greater than or equal to. And then we want to think about where the shading should be. Well, it says 4 is greater than, y is greater than 4x minus 3, so we know we want, it's saying here that 0 is greater than -3. That is true, so we want to shade the side that's true. So we're going to shade this side over here. Now we're going to go ahead and draw the or create the solution for y is greater than or equal to -2x plus 3. So our y-intercept, again it's in slope-intercept form, our y-intercept is +3. And our slope is -2/1. And so we're going to add some points to show that slope. And then our line here is solid because it's greater than or equal to. And we have our shading that we need to add. And this is saying that 0 is greater than or equal to 3, which would be false. 0 is not greater than 3 for testing the ordered pair 0, 0. And so our shading then would be over here, because 0 is not bigger than 3. So 0 is false, so we shade the other side. Now we look for the space where the red and the blue overlap, and that would be here. And so this area is the solution for this system of inequalities where the shading overlaps. Let's look at the second example here. So the second example, our first equation here is in slope-intercept form. And so our y-intercept is +3. And the slope is -5/1. And it is going to be a solid line because we are dealing with less than or equal to. And the shading, testing the point 0, 0, is 0 smaller than 3. It is, so that side is true. So I shade in this side. And now I have an inequality here with one variable. So this is the same. You can consider the mnemonic device Hoy-Vex. And I was saying it's the same as if you had an equation. And so this is going to be a horizontal line. We're going to be at -2 here. So I'm going to put a dot at -2 on the y-axis, and then it would be a dashed line going straight through. Now this is saying that 0 is greater than -2. That is true. We want all the values bigger than -2. So it's going to be everything above. So now we look and we see that we need to be on the bottom side or the left side of the blue line and above the red line. And where does that overlap? That is over here. So this black area shaded, that is now the solution for this system of inequalities. Let's go ahead and consider these last two examples here. This first one again is one variable. It says y is greater than 3. So we would put a dot at 3 on the y-axis. Let's see here if I can drag this dot where I want it, and then bring her back down to a good size here. So we have a dashed line going then horizontal again through the y-axis to represent y is greater than or equal to 3. And the values that are true then are above again this line. Let's get some blue shading here. And then our next equation here is y is greater than or equal to -x plus 1. So our y-intercept is 1. And our slope is -1/1. And so up, rise over run, right, fall, and go to the right to create a negative slope. And a solid line for the greater than or equal to. Now the shading, y is greater than or equal to, so we would shade above if we were testing, or excuse me, let's look at that again. Is 0 greater than 1? And that is not true. And so we need to, 0 is right here in respect to the line. So this is false. 0 is not greater than 1. So we need to shade the other side. And now we're looking for where does the red and blue overlap, and that's going to be in this portion right here. In our last example, it's going to be the same thing, but notice that these two equations are in standard form. And so we would graph using the intercept method. So if I found the x-intercept here, 9 divided by 4 would be 2.5. So I'm going to go to about 2.5 on the x-axis. And then 9 divided by -3 is -3 on the y-axis. And it will be a dashed line. And now we're going to test the 0.00. Is 0 less than 9? And it does work, and so that shading would go on the side of 0, 0. And our y-intercept and our x-intercept over here, 6 divided by 1.5 is 4 on the x-axis. And plugging in 0 for x, leaving us with the y, 6 divided by 3 is 2. So a positive 2 intercept. And a dashed line. And now where should the shading be? Is 0 bigger than 6? It is not. So here, 0. So we need to shade the other side. So it's all of this space above the red dashed line. And now where do they overlap? And that would be this area here. All right, that concludes our systems of inequalities examples.